Hi, hello, how are you? I am doing number 22, question number 22 on this LeetCode situation. I'm going to be doing my, um, what's it called? My solution in Python. It's the morning. I haven't had caffeine. It's the same thing, different day. So without further ado, number 22, generate parentheses. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. Example 1, n equals 3, so that's 3 pairs. So that's 3 open, 3 closed. 3 open, 3 closed. Okay. And then the same thing with 1. Okay. So these are the constraints. This feels like it shouldn't be medium. It feels like it should be easy. Because if it were me, and it is me, I would just do a helper function recursively. Like I just feel like that's the recursive approach is going to be the best approach for this. So actually, let's start with a base case so that if n is 0, then it just returns an empty list, and then we'll make a list to store all the generated combinations, because that seems like probably the better way to start. And then we'll do the helper function to generate combinations, and then within that we'll do the base case for that. So if both left and right are there, then it will put it to that generated list. And then we should do maybe an if function so that if you need to add, or if you need to add a left parentheses because there's anything remaining. So like if they say 3 and we already have 1, we need to generate 2 more parentheses. And then we should do the same thing for right. So if there are more left parentheses, and you have to generate the right parentheses. And then we'll just use that helper function to return to generate combinations to return to that, starting with an empty string to return to that list, and then we'll return those generated combinations. So let's start with if n equals 0. Then we return that empty list, and then that list we're going to call combinations. And that's where this is all going to be stored. So let's use that helper function to do that recursive call. So we're going to say def backtrack s left right. And then let's do that base case. So if left is 0 and right is 0, then it just adds it to that list. So if left 0 and right 0. Wait. We're going to say combinations and s, and then return. Okay. So then let's do adding left parentheses if we need to add more. So if left is more than 0, so like we don't have standing ones, backtrack s plus left parenthesis, remove that, and then we're going to say left minus 1 and right. And then we're going to do the same thing with the right. So if there are any remaining left, so if right is greater than left, we'll backtrack again and add those rights. That way we're going to get that these lefts will always have a right, which means it will always have that output. So let's say if right is left, then we will backtrack s again, but we're going to do it with the right parenthesis, left right minus 1, because that makes the most sense to me. So we will call that helper function to generate the combinations again, starting with the empty string. And it's going to be backtrack empty n. Yes, an n. I almost did s. And then we want to return the combinations list. So we have our base case and it returns an empty list. We have the list for the combinations. We have the helper function. We have the base case that we add to the generated list. And then if we need to have more lefts, like if it's a 0, that means there's no more lefts remaining and requested. If we need more lefts, then we add a left. If we need more rights because there are more lefts, or we need more, whatever, you get what I'm trying to say, then we add that right, and then we'll call that function to the combination, starting with the empty string, and then return the combination. So let's run this. Oh, that's hot. That is hot. That was quick. Dope. It ain't if we don't submit, though. Yeah, that's what I'm talking about. Ooh, she's nice. That's good. That's good. That's good. Okay. I was gonna just do one, but we might as well go to the next question. I take that back. Son of a big pond. Why is it always gotta be? Why is she always gotta be like that? Okay, we'll save this for the next video. I need to leave. I need to drink caffeine. Thank you guys for watching. I'm gonna read through this question and I'm gonna come back tonight when I have caffeine and I am awake and do it. Thanks, guys.